Thank you for joining us. We wanted to go over the module that can help you calculate the required seismic forces on a structure. This is over in the General tab of the Project Manager, and we have earthquake forces. It's on the General tab because we're assuming that your site is just has one location in a project, and it allows us to do all the earthquake force requirements for that particular location. So we start out with a General tab. We have the 4 different occupancy types. So we'll choose a type 2. Ground motion. We have 3 different ways of doing ground motion. This program has a complete list of every city in every state in the country in it. And so we'll just select California. We're in Newport Beach, so we'll go down to Newport Beach and click on that. And what we've done is we've related the city names and the zip codes, the latitude and longitude locations, and those are correlated to the NEHRP database of seismic acceleration values. And the result here is an S sub S and S sub 1 acceleration values for this particular location. You can also enter S sub S and S sub 1 directly that you use in the program, or if you want to enter in a specific latitude and longitude and have it look it up in the NEHRP table, you can do that too. For right now, we'll just go by this with this database value. Let me take 1 second to mention that this program is not, this particular module does not have documentation, because it's basically an exact application of the reference sections in the ASCE 705 code for determining seismic factors. And to actually fully document this program, we would basically just have to copy everything in the ASCE code, and that would be some form of copyright infringement. But the application of what the ASCE code demands of you as an engineer, that is not a copyrightable violation, because we have to use it as mandated in the entire nation. So we'll go down to site class and category. Again, here notice here's the ASCE references, the pages, table numbers, equation numbers if needed. So you can select the various soil types. Go down here and select your resisting system. Basically, these buttons categorize the various resisting systems that are summarized in this ASCE table, and where you can just go down and select a particular system. You also have the option of specifying a flexible diaphragm. It changes omega in some later calculations. Okay, after we've selected a resisting system, we can go to redundancy factors. You can either use the calculated redundancy factor for the seismic design category, or you can force it to 1.0. Building period. There are several ways of entering the building period. You can enter it directly. You can use an approximate method, and of course all these are right out of the code. We have our long period transition entry down here. We can use an approximate period by calculating a number of stories, and another method for using an approximate period for masonry structures by adding the various heights. So we have those various ways of entering the building period. Again, this is right out of the ASCE code. Seismic response coefficient. We have some check boxes to modify that coefficient here. And we also have a selection whether you're going to be needing these factors for strength design combinations or allowable stress combinations, meaning the actual load combinations used in your design. Moving on, we can create it. So, excuse me, this is the basic seismic response coefficient that you get after doing ground motion category, soil category, resisting system, building period, etc. Moving on, for multi-story structures, we can create a table of weights and heights, sort of a mass weight and height, so you can get your distribution of forces up the various levels. This, of course, is an obvious code requirement's been there for 20 years. That'll generate your forces per level, and in turn those can be carried over to this table where they will generate the individual force for the diaphragm at each level. Wall anchorage basically just gives you a load per anchor, and based upon the various seismic factors it gives you some minimum anchorage forces that you have to design for. And then finally, if you do have the case of combined load effects where you need to do specific calculations for dead and seismic load combined, you can use this. So this is straight out of the ASCE code. Nothing fancy. It was a heck of a lot of work to try to figure out the code to get everything to be able to proceed in the right order to determine all your factors in a logical manner as the code intended. That's all done for you here. So I think that you'll find this very, very useful. Thanks for joining us. Just use support@intercop.com for any further questions. Thank you.